been talking about convergence and divergence, there actually are two different types of convergence: absolute convergence and conditional convergence. So let's look at the difference between those two. So let's assume my series does converge. Then it actually converges absolutely if the series summation of absolute value of k also converges. So I need my original series to converge and the absolute value to converge, then it would converge absolutely. Otherwise, we say it converges conditionally. So if the summation of the absolute values converges, then it will converge absolutely, otherwise it will be conditional convergence. And there is a nice theorem that helps us relate these in other ways as well. It essentially tells us that absolute convergence implies convergence. So in order to converge absolutely, I need my original series to converge. And then, if that happens, I need the sum of the absolute values to converge. However, essentially what this says is if I know that the sum of the absolute values converges, then the original series also converges. So that one does go both ways. So let's look at some examples. Here I have this series k equal to 1 to infinity of -1 to the k plus 1 over the square root of k. And I want to know if this converges absolutely, converges conditionally, or if it diverges. So let's start by seeing if this converges. This is an alternating series, so we need our alternating series test. We need it to be able to be decreasing. We should feel pretty confident that the square root of k is less than or equal to the square root of k plus 1. Square roots of bigger numbers are bigger. If I take the reciprocal of both sides, I get 1 over root k is greater than or equal to 1 over root k plus 1, since taking the reciprocal does switch the inequality. Therefore, I have ak is greater than or equal to a sub k plus 1. So we can definitely say that it is decreasing, and now I need to use my other part of the alternating series test. That wants me to look at the limit as k goes to infinity of 1 over root k, which we know is 0. So according to the alternating series test, this does converge. So now we need to know, is it absolute convergence or conditional convergence? So let's think about the absolute value. So I'm considering the sum as k goes from 1 to infinity of the absolute value of -1 to the k plus 1 over root k. The denominator of this fraction right here is always going to be positive. So I don't need to worry about the absolute values on the bottom of the fraction. The top of the fraction is just either a 1 or a -1, both of which have an absolute value of 1. So this is the sum of k equal to 1 to infinity of 1 over root k. And the p-series test tells me that that diverges, since the exponent is 1/2, which is less than 1. So I have that the original series converges while the series of the absolute values diverges. Therefore, this is conditional convergence. This series does converge conditionally. The next one we'll look at, the sum from k equal to 1 to infinity of -1 to the k plus 1 over the square root of k cubed. We start by deciding if this series converges or diverges. We know we have that k cubed is less than or equal to k plus 1 cubed. We can take the square root of both sides. And then when I take the reciprocal of both sides of this, my inequality flips. So I know that ak is greater than or equal to a sub k plus 1. So that is the first thing I need for convergence. The second thing I need to look at is the limit of the terms. The limit as k goes to infinity of 1 over the square root of k cubed. The top of the fraction is always a 1, and the bottom's getting larger and larger and larger. So this limit is equal to 0. So this does converges. Let's now look at the absolute value series. So I have the sum from k equal to 1 to infinity of the absolute value of -1 to the k plus 1 over the square root of k cubed. We know that the denominator of this is always positive, so the absolute value is irrelevant. And the top is just 1 or -1. So the top is absolute value is going to be 1. So this is equivalent to the sum from k equal to 1 to infinity of 1 over the square root of k cubed. We see that the exponent of the k on the denominator is 3 over 2. So by the p-series test, 3 over 2 is greater than 1, so it's going to converge. So since the original series converges and the series of absolute values converges, I have absolute convergence.